Hey fellow problem solvers, Colfax Math here. Today I'm going to go over fractions for any sort of standardized math exam, kind of specifically for the ASVAB military placement exam. I'm going to work with this book right here. This is a great book. A lot of people have been asking me if there's supplemental materials they could use as I go over the ASVAB military entrance exam, and I went through a bunch of them and this is the best one. I'll put a link to it in the description for digital download, or you could buy the actual paper book on Amazon. What I'd highly recommend you do is you watch these videos with paper and pencil. You pause the video, do the problem before I do it, and then watch how I do it. I'm going to do a lot of fraction problems today, so hopefully you've gone through some of the previous videos on either the mathematical knowledge or arithmetic reasoning tests, and you've identified where your strengths and weaknesses are. And today I'm going to hopefully fill in some of those weaknesses on fractions. So we're going to do a lot of practice problems here. You know, the way you learn how to juggle, practice. The way you learn how to do math, you got to practice as well. All right, this is again chapter 1 in this ASVAB Math book. This is what I'm going to work on today: simplifying fractions, adding, subtracting fractions, multiplying and dividing fractions, adding mixed numbers, subtracting mixed numbers, multiplying mixed numbers, dividing mixed numbers, more practice, and then if you have the book, there are more answers involved as well. All right, rather than go through and explain all of those different topics, I'm just going to break it down to one topic at a time. Then we're going to do some practice problems. Ideally, you got paper and pencil out. You're doing the practice problems before I'm doing them. So let's start with simplifying fractions. So what I'm looking for is I really need to know my multiplication tables really well. What I'm trying to do is reduce that fraction. That's another way to say it, to simplify it. I want to bring it down so it can't be reduced anymore. So right here on the first one, 2/8, I'm looking for a number that will go into 2, but will also go into 8. So there's only one number that'll do that. That's a 2. 2 goes into 2 1 times. 2 goes into 8 4 times. So the same fraction, 1/4, is the equivalent of 2/8. However, it has been reduced. And the check is, does that have the same weight? If I do 2 divided by 8, I'm going to get 0.25. If I do 1 divided by 4, I'm going to get 0.25. Or another check is I could always take this, multiply it by a value of 1. This is really a very big idea in math. The value in the numerator and the denominator is equal. This thing's just a 1. If I multiply a number by a 1, it should have the same weight. I multiply across the top to get 2/8. So I could see I did that one correctly. Go ahead and pause the video, do number 2, and then unpause, watch how I do it. The number that goes into 5 and 15 is only a 5. 5 goes into here once, 5 goes into here 3 times. So this is the equivalent of 1/3. You don't have to get it right away. You know, you could continuously reduce, and we'll get to that in a little bit. Pause the video, do number 3. 10/90. Well, 10 will go into each of those, so give me 1/9, and I can't reduce any further than that. Number 4, 12/16. Well, 3 will go into both of those. No, it won't. 3 won't go into 16. 4 will go into both of those. 4 goes into 12 3 times. 4 goes into 16 4 times. I look at it, nothing more to reduce. Keep going over here. Anything that ends in a 5 will be factorable by 5. 5 goes into 25 5 times. 5 goes into 45 9 times. So you can really see, if you don't have your multiplication tables down, these are near impossible. So if I say 5 goes into 45 9 times and you can't come up with that pretty quick, pull out your multiplication table and just kind of study that a little bit every day so that it comes to you really pretty quick. Okay, I'm on the next section right now. Find the sum or difference. Sum means to add, difference means to subtract. You know, when you're in school, you actually learn addition and subtraction before multiplication and division because it's easier to progress that way. However, with fractions, it's different. Adding and subtracting is a lot harder than multiplying and dividing when it comes to fractions. So there's a really key rule here. The key is that the bottom number, the denominator, has to be the same. So if the bottom number is the same, it's pretty easy. If the bottom number is not the same, you got to make it the same and then add or subtract. So let's do a few of these and then build on our skills. Here I have the bottom number, the denominator the same. Then it's pretty easy. I add across the top. 3 plus 2 is 5. And I keep the bottom number. And then I get 5/10. Now that I've done that, I go back to the previous section and I reduce that fraction to get a half. And then I'm done. Number 10, same thing. Pause the video, do that problem, and then see how I do it. First thing I do is I make sure the bottom number is the same. It is. I have subtraction, or the difference. 4 minus 1 is 3. I keep that bottom number, 9. Then I want to reduce. 3 goes into 3 1 times. 3 goes into 9 3 times. Okay, number 11, I want to make sure the bottom number is the same. It is not, so I have to get it there. The way I get it there is I multiply by 1. I can't do whatever I want to either side because I'm really not working on either side. It's really an expression. So I got to multiply one of these by a value of 1 so I don't change the value of it to get that bottom number the same. So I'm going to multiply this term on the left by 5 over 5. The whole reason I do that is to get a 15 on the bottom, which I already have right there. Then my bottoms will be the same. Then I go across the top. So you could see this idea is very similar to the previous idea of reducing fractions. So this first term is now going to be 5 times 2, 10. 5 times 3, 15. So I have 10 fifteenths plus 6 fifteenths. Add across the top to get 16, keep the bottom number the same, 15ths. Well, that number in the top, the numerator, is greater than that number on the bottom, so I want to turn it into a mixed number. 15 goes into 16 one time with 1 left over. So these are equivalents, but this makes more sense. This is a mixed number. So if the number in the top is greater than the number in the bottom, you put that number in there, and then the remainder goes back in there. All right, pause the video, do number 12. Again, check the bottom numbers. They are not the same. I got to get them the same. I'm going to multiply this second term by 3 over 3. A little crowded here. That's going to give me 17/24 minus 5 times 3, 15/24. The whole reason I did that was to get that bottom number the same. Now that it's the same, across the top, 17 minus 15, 2. Keep that bottom number the same, 24. Then I want to see if I could reduce it. 2 goes into 2 1 times. 2 goes into 24 12 times. Final answer, 1/12. Go ahead and do these problems right here. The answers will be in the book. But you got to do a lot of practice. Getting the idea is the first step. Practicing continuously is really the way you solidify it and get it to make sense. All right, next section, find the product or quotient. Product means multiplication. Quotient means division. I'm going to put division on hold for a second. We'll go to product first, and then we'll go back to quotient. There's a rule for that. So I could just multiply across the top, multiply across the bottom, and then reduce afterwards, or I could do my reducing ahead of time. These are pretty big numbers, so it's probably easier to reduce ahead of time. I could reduce in any way across the top and bottom. So I have 5 over 27, 9 over 25. 25 and the 5 will cancel. 5 will go into here 1 time, into here 5 times. Again, going back to the first thing we started with, reducing fractions, you can see how math is so cumulative, built on the previous section. And I still got this 9 over 27. Well, I see those are reducible. 9 will go into 9 1 times, 9 into 27 3 times. I've reduced that thing down. Now I just multiply across the top, 1 times 1, 5 times 3. Final answer, 1/15. I check it, see if it gets reduced. It can't. There I am. Pause the video, do this one, then I'll do it. 15 and 65, they end in 5s. 15 might go into both of them, but I see the 5. So let's say 5 goes into 15 3 times. 5 goes into 65 13 times. Is that right? 50, 65. 12 and 72, both divisible by 6, also divisible by 12. 12 will go into 12 one time, 12 into 72, oh no, it won't, will it? 50, 60, 6 times. Yep, in there 6 times. So now in the numerator I have that 13 and the 1, kind of crowded. I get 13, multiply across the top, multiply across the bottom, double check that I can't reduce it. Final answer, 13/18. All right, going back to the quotient problems over here, dividing fractions, the rule is multiply by the reciprocal. And it's not, the order does matter. So the way I'm going to divide this fraction is I'm going to keep that 2/9 the same. I'm going to turn that into a multiplication and flip that over. Seems kind of like a complex algorithm, but it actually kind of makes sense. So the way I divide fractions, again, is I multiply by the reciprocal. So I turn that to multiplication, flip that over. Then I'm at a multiplication problem just like these. I see if there's anything I could reduce. 3 goes into 3 one time. 3 goes into 9 3 times. 2 goes into 2 one time. 2 goes into 4 2 times. Multiply across the top to get 1. Across the bottom, 1/6. Okay, I know that's a tricky one. Let's go ahead and pause the video, do 18, then I'll do it. So I keep the first fraction the same, turn the next thing into multiplication, and then flip that thing over, 35/28. Then I see if I could reduce. 5 goes into 5 one times, 5 into 35 7 times. 14 goes into 14 one times, 14 into 28 2 times. Across the top gives me 7. Across the bottom is 2. I ended up with the larger number on top, so I got to see how many times 2 goes into 7. 2 goes into 7 3 times with 1 left over, so I convert that to a mixed number. 7 halves is the equivalent of 3 1/2. I'm using all my skills that I talked about prior to this, and you can really see how important your multiplication table is. I'll say it again, if you don't have that thing dialed, you got to go back and dial it in, because it's hard to see that 14 and 28 are going to reduce unless you got your multiplication tables pretty good in your head. Next section, find the sum. Again, sum means addition. We have mixed numbers now. So the way I'm going to do this, I'm going to take that whole number, multiply by the denominator, add the numerator. Right, kind of the reverse of what we did before to take that mixed number or that fraction that had a larger numerator than denominator. So again, I go 2 times 5, 10, plus 1. I have 11/5 plus the whole number times the denominator, 1 times 5, 5. 5 plus 2, 7. I have that common denominator, so I just add across the top to get 18. Keep that bottom number, they're the same, 5. And then I'm going to reverse that process. So I turn that mixed number into an improper fraction. I'm going to go backwards to do this. 5 goes into 18 3 times, 15 with 3 left over, 3 3/5. See if that even makes sense. 2 and the 1 add up to 3, 1/5 and 2/5 add up to the 3/5. Go ahead and pause the video and do some of these problems, and then the answers will be in that downloadable doc. I'll do one more. Number 22, 5 times 9, 45, plus 1, 46/9, plus 18, 2 times 9, 18, 18 and 7, 25/9. I have the same denominator, same bottom number, so I add across the top to get 60 plus 11, 71/9. Keep the bottom number the same. 9 times 6 is 63. 9 times 6 is 54. 9 times 7 is 63. 9 times 8 is 72. So 9 goes into there 7 times. That was 63 with 8 left over. So it's going to be 7 and 8/9. See if that makes sense. 5 and a 2 is 7. 1/9 and 7/9 is 8/9. Next one's going to be a little harder because now we're not going to have a common denominator. We're going to turn it in to a number like this. Then we're going to get a common denominator. Then we're going to add across the top, keep the bottom number the same. All right, next section. Find the difference. Again, difference means subtraction. All the same rules apply. I have mixed numbers. I'm going to convert them into fractions. And then I'm going to make sure the bottom numbers are the same. Then I'm going to subtract across the top, keep the bottom number same. So same thing, 5 times 3, 15, plus 1. So I have 16/3, minus 4 times 3, 4 times the denominator, 12, plus that 2, 14/3. I have the same bottom number. I'm going to subtract across the top to get 2, keep the bottom number the same, 2/3. Go ahead and do these problems. Again, the answers will be, in that download or in the book. I'm going to jump down to 30. So make sure you pause the video and do up to 30 and then do 30 and then see how I do it. Make sure you're on the right pathway. 6 times 12, 12. Sorry, 6 times 2, 12. 12 plus 1, 13. So I have 13 halves minus 3 times 3, 9, plus 1, 10/3. So now I need to be able to subtract them. Rule is I have to have a common denominator. I can't just multiply this by something to get to a 3. I'm going to have to do a few things. I'm going to have to multiply this by a 3/3 to get a 6, and multiply this by a 2/2 to get a 6, to get that common denominator. 3 times 13 is 39, over 3 times 2, 6, minus 10 times 2, 20, over 3 times 2, 6. Now I have that common denominator. Now I could combine the top. 39 minus 20 is 19. Keep that bottom number the same, 6. 19 is greater than 6. 6 goes into 19 3 times, right, to give me 18 with 1 left over. And I'm left with 3 and 1, 6. That can't be reduced any further. If you're getting those right, you're putting together a lot of pieces. All right, let's move on. Number 35, find the product. Again, product means to multiply. I have a mixed number. I'm going to put it in fractional form. Remember, multiplication is a lot easier than a distance subtraction. With multiplication, I just go multiply across the top, multiply across the bottom. Division, remember, I multiply by the second fraction flipped over. I multiply by the reciprocal for division. Okay, so I have 1 times 2, 2, plus 1, 3 halves, times 2 times 7, 14, 14 plus 3, 17 sevenths. Anything I could reduce, I don't see anything that'll reduce down. 3 times 17 is 51. 2 times 7 is 14. And then 51 is greater than 14, so I got to figure out how many times 14 goes into 51. 3 would be 42, so it's going to go in there 3 times, right? 3 times 14 is 42 with 9 left over, so 3 and 9 14s. These are pretty hard. Pause the video, work your way through these, and then check them against the answers. I don't want this video to go on forever, so let me jump down to the next section. Very similar to this section. The only difference is I'm doing division. So let's convert these mixed numbers. 1 times 3 is 3, plus 1 is 4. So I have 4/3. I am not going to divide. Well, actually, I'll put the division sign here. 1 times 3 is 3, plus 2 is 5. So I have 4/3 divided by 5/3, which is 4/3 times the reciprocal, 3/5. Can I cancel anything? Yes. The 3's will cancel to be a 1 and a 1. Multiply across the top, 4/5, and that's my answer right there. Make sure you work your way through all these problems. That practice is really what makes it stick in your head and make it have sense. All right, so here are some of the answers to the problems right here. You could pause the video and then check your work against these answers right here. Give it a few seconds and I'll scroll down a little bit further. I know it's hard to pause the video and get these answers off of here. You have to have a notebook in front of you. If you're not going to buy the book or download it and print it out, you have to have a plain notebook in front of you with pencil, and you got to really kind of work back and forth in this video. But I sure hope this is helping fractions make sense. They're not that hard if you break it down into simple rules. So again, step one is to reduce your fraction. So if you have 5 over 25, you're looking at what numbers go into both of those. Well, 5 will go into both of those. So that 5 over 25 will reduce to 1/5. Adding and subtracting is actually harder than multiplying and dividing. The rule for adding and subtracting is you have to have the same bottom number. That's called a common denominator. So before you could add or subtract, you have that common denominator. Then you add or subtract across the top. Keep that common denominator. Multiplication is pretty easy. You multiply across the top, multiply across the bottom. You could reduce first or reduce afterwards. Division is not that different than multiplication. The difference is division, you multiply by the reciprocal. So you change that division sign to multiplication, take that second fraction, flip it over. And then you have to be able to reduce and go from mixed numbers to fractional form and fractions back to mixed numbers. Kind of covered all that. Hopefully that made a little bit of sense, and hopefully you're doing a lot of practice to really get it solidified. Well, thank you for watching. If you're new to the channel, think about subscribing. I appreciate you watching and supporting this channel. Thank you.